Hi all. Now in this video, I am going to explain how to control the speed of a single phase induction motor using a single phase inverter. I am Dr. V. Kritika. This is the circuit that helps us to control the speed of the single phase induction motor. In my previous video, I have explained about the speed control of single phase induction motor using a triac diac pair. If you have any queries, you can put your comments in the comment section. Now, you all know that an inverter is one which works with the DC supply as the source. But right now I have an AC supply. So we'll try to understand what is available in the circuit first. We have an AC supply, single phase AC supply, rectifier, filter, then an inverter. And the final one is the single phase induction motor. So to control the single phase induction motor using an inverter, I need a DC supply, which in turn requires a rectifier and a filter as the supply is a single phase AC supply. Okay, now I'll explain how the rectifier works and then how the supply is passing to the inverter, and through this inverter how we try to control the motor. Okay, this is the single phase AC supply. You all know how a rectifier works. If not, I'll explain now. We have 4 thyristors here. This is the bridge circuit, and for an AC supply we have a sine wave. So this is called as the positive half cycle and this is called as the negative half cycle. For the positive half cycles, a pair of thyristors work. So for the positive half cycle, T1 and T2 works, and for the negative half cycle, T3 and T4 works. If you are not aware of the rectifier, I'll explain how T1 and T2 alone works and T3 and T4 doesn't work. You know what is an SCR or a thyristor means? A thyristor or an SCR has 3 terminals: anode, cathode and gate. A SCR works only if and only if it is forward biased and also the gate potential is given. What do you mean by forward biased? If the anode is connected to the positive and the cathode connected to the negative, then it is called as forward biased. And the gate terminal should be given a positive potential. Under this condition, an SCR works. SCR will work now. Let us assume that we have a positive half cycle now. During the positive half cycle, let us check which thyristors of these 4 will be conducting. For our AC understanding, I'll mark it as plus here as of now because this terminal will be positive and this terminal will be negative. Okay. During the positive half cycle, this node will have the positive potential and this node will have the negative potential. When it is positive, T1 will be forward biased whereas T4 will be negative biased as cathode is connected to the positive. Likewise, when this node is negative, T2 is forward biased whereas T3 is reverse biased as it is negative. Anode is connected to the negative potential. So right now, as I said, during the positive half cycle, T1 and T2 is going to conduct. Likewise, if I assume now I have the negative half cycle, then this node is negative and this node becomes positive. So what happens by this time? This node is negative, which means T1 will not conduct, whereas T4 is forward biased, so it is going to conduct as negative potential is connected to the cathode. Same manner, this node is having a positive potential as it is a negative half cycle. Hence, T2 will not conduct now as it is reverse biased, whereas T3 will conduct because it is forward biased. This is how we get a DC supply. Though there is a change in positive and negative half cycle in the source side, you should note one important point right now. This node will have will just the same potential, which means though T1 and T2 conducting or T3 and T4 is conducting, the current will flow by this way. I'll show you with a highlighter. See, during the positive half cycle, current passes from this node to this node through T1 and through this node and then through T2, then back to the supply. Similarly, during the negative half cycle, the current comes by this way to the node T3, then return back through T4 and through this node it comes back to the supply. So what happens is at this node, I've marked this. At this node, it is always positive and negative because the current direction is flowing from the upper node to the lower node. That is why I have given a dot in the upper line as well as in the lower line, which means during T1, T2 conduction also the current flows by this way, whereas during T3 and T4 conduction also the current flows by this way. Yes, so there is no change in the current direction, which means we have a positive supply in the upper half and the negative supply in the lower half. And this is how a AC is converted to a DC. Hope now you understood how a rectifier works. Next, I'll help you to understand how an inverter is going to control our single phase induction motor speed. You all know this filter is meant to control the harmonics and the ripple when we have a rectifier as well as filter. So that is why LC filter is available in the circuit. Now, as the rectifier has done its job, we have the DC supply as of now. We'll check how an inverter works. It's in the same manner that the positive supply is coming through T3 through the motor and comes back through the T6. Now you should understand one important point, that a single phase induction motor, from the name itself, will have an alternating supply, or like it will work by this way. So we'll understand this. Initially the supply is DC and the output will be an AC in case of an inverter. A rectifier converts AC to DC, whereas an inverter is just the reverse of it, which will convert a DC to AC. So we have the supply as DC here, and that is converted through the inverter by the inverter as a AC, which will be fed to the motor. So whenever there is a change here, automatically that will change this, which means whenever there is a potential change across these two nodes, there will be a change in the voltage fed to the motor also. Now the supply is passed to T5, then the current passes through motor and through T6 and then comes back. Again, this is when T5 and T6 is conducting. Now what happens when T7 and T8 is conducting? See, when T7 and T8 is conducting, the supply goes by this way. It is through T7, then back through T8 and just return back here. Yes, so this is how it is getting inverted. Now you should observe that when T5 and T6 is conducting, the current flows by this way, which means from upper to lower, whereas when T7 and T8 is conducting, the current comes by this way and goes through the motor from down to up, then closes through the T8. So this is how we get the AC supply. Fine, this is all the operation of a rectifier and inverter. Now let us understand how the speed is being controlled by using this inverter. We have a thyristor here, T5 to T8, which means 4 thyristor pair is used. Whenever there is a change in the firing angle or the triggering angle, obviously there will be a change in the potential across these two nodes. Whenever there is a voltage change across the motor, then that is going to change the speed of the motor. So this is how we try to control the speed of the motor. This can also be changed by changing the firing angle of the rectifier thyristors also. This will be changing the voltage across the inverter, and if you want to change the voltage across the motor, then the firing angle of the inverter has to be changed. If there is a variation in the firing angle of the inverter thyristors, then there will be a change in the voltage fed to the motor. In turn, there will be a change in the speed. By this way, we control or change the speed of the single phase induction motor. Hope you understood. If you have any queries, put it in the comment section. Thank you.